Here are explanations of the problems on page 32 of Erdan's textbook. Suppose that I wanted to know something about the age of customers at my new pizza palace. I take the first 6 people that walk through the door and ask their age in years. I get the following scores: 6, 20, 34, 42, 50, and 56. First, I calculate and report the range of this distribution. The range is the distance between the highest and lowest scores in a distribution. The highest score is 56. The lowest score is 6. Therefore, 56 minus 6 equals 50, which is my range. Next, I'm asked to calculate and report the variance of this distribution. First, we would calculate the mean. 6 plus 20 plus 34 plus 42 plus 50 plus 56 equals 208. 208 divided by 6 equals 34.66. The 6 is 5 or greater here, which rounds to 34.67. Then we calculate the square deviations for each score to make each deviation score positive. So I would begin by saying 6 minus 34.67 squared equals 821.97, and so forth. And I would sum this and come up with 1781.33. Then we divide this sum of squared deviations by n minus 1, which is 1781.33 divided by 5, which equals 356.27, which is the variance. And here I wrote up the formula for calculating the variance for you. So here we have the population variance, which equals to sum each score in the distribution minus the population mean squared divided by n, or the number of cases in the population. And here are the symbols and their meanings for you for calculating the variance. Question 3. Calculate and report the standard deviation of this distribution. The standard deviation is just the square root of the variance. S here represents the sample standard deviation. So S equals the square root of 356.27, which equals 18.88, which is the standard deviation of the sample. Question 4. We're asked to write a sentence or two in which you explain, using your own words, what a standard deviation is in general, not this particular standard deviation. A standard deviation is roughly the average difference between the individual scores in a distribution and the average for the distribution. A sample standard deviation is an estimate of the population standard deviation. Question 5. Pretend that this distribution of scores represents a population rather than a sample. Calculate and report the standard deviation and explain what it tells you. We can use the sum of the squared deviations from question 2 again, which I wrote out for you, the sum of which was 1781.33. We divide this by n, or the number of cases in the population, and we get 1781.33 divided by 6 equals 296.89. Then we would find the square root of this variance. The square root of 296.89 equals 17.23. Right here. This is the standard deviation of the population. In this population, the average difference between the scores in the distribution and the population mean is 17.23 years. Question 6. Explain why the standard deviation you reported for question 3 differs from the standard deviation you reported for question 5. Well, in question 3, we divided the sum of squares by n, in this case the number of scores in the sample, minus 1, because it was sample data, producing a larger variance and standard deviation than we found in question 5 when we used n, or the number of cases in the population, as the denominator in the variance and standard deviation formulas. Question 7. Think of an example that illustrates why it is important to know about the standard deviation of a distribution. And Dan described one example. I often consider student evaluations of my teaching and strive to be the best teacher or professor possible. If I get an average rating of 4 on a scale from 1 to 5, I want to know whether almost all of my students rated me a 4, producing a small standard deviation, or if most of my students rated me a 5, but a few really didn't care for my teaching and gave me a 1, producing a larger standard deviation. Did all of my students feel lukewarm about my teaching, or did most of them approve and a few of them disapprove? And over here on page 3, I included symbols for calculating the mean of a distribution. So here we have the population mean. Here we have the sample mean, the symbol for sample mean. Here's the symbol for the sum of or to sum. Here's the symbol of an individual score in the distribution. Here we have the number of scores in the sample, and here we have the number of scores in the population. So you can use the information from the explanations I've just given you for your assignment this week, and I look forward to looking at your work.